All right, in this video, we're going to be talking about statistical bias. Now it says, recall Lay's potato chips one last time. One sample that was collected had the results shown below. If the true mean of all Lay's bags is really 28.3 grams, as claimed by the company, this sample appears to have problems. The sample mean is far below the true mean, and in fact, all the bags are below the true mean. So, true mean is supposed to be right here, 28.3 grams, but every single one of our samples, our data points in the sample, is below that. So this discrepancy between a population parameter and a sample statistic is known as statistical bias, which can result from many different sources. Two broad categories of statistical bias are biased sampling methods and biased statistic. So it says, give an example of a biased sampling method. So whenever you're sampling, you want to be able to sample from different areas, right? So if a biased sampling method would be something like if you collected all the chips from a single vending machine. So if you collect all chips from a single vending machine. This would be a form of biased sampling because you're getting them all from the same source. What if that one single source was inaccurate compared to the rest of the entire population? You want to spread out your sampling. Now it says, sometimes researchers spend vast resources, such as time, money, and effort, to get a great sample and then still end up with a biased statistic. For example, something could be wrong with the data collection method. What would happen after selecting the sample, for example, potato chip bags, and before calculating the statistic that could result in a biased statistic? So if you're weighing bags of chips and you're getting something that's way off the true population mean every single time, something that could be happening is that your scale is off. You could have an inaccurate scale. So the scale could be inaccurate. It says, if in fact the method of sampling has introduced bias, one reason for this might be that the sample was actually non-representative of the population, or non-representative sampling. So non-representative sampling, I'm going to highlight that, is when the sample does not represent the differences in a population. For example, the students in this class are mainly seniors in high school. Therefore, they do not represent all students in the school. If only the football team or only the volleyball team were surveyed at most schools, the sample would have all males or all females. What other situations could be responsible for bias, and provide examples where possible? So I'm going to give a couple examples. An example of under coverage. Okay. Under coverage could be entire segments of the population are missed. And then the other one could possibly be overlapping strata. So overlapping strata could result in repeated responses. For example, if you were going classroom to classroom asking a survey question, you could ask first period math these questions, and then in second period go to English. And there could be a student in the first period math that is also in second period English and is answering this survey twice. So that is an example of overlapping strata. All right. Now, number 4 says biased statistics can result from a variety of problems during the data collection process. Record your thoughts or information you have located through research regarding each of the following sources of statistical bias. So response bias. This occurs when the responder lies, or perhaps because they are embarrassed to give their real opinion or tell the truth. Response bias can occur if responders have a faulty memory or strong feelings, such as like or dislike, towards the interviewer. So strong feelings. And then non-response bias occurs when intended participants may not be able to be reached or refuse to participate. Observer effect occurs when the participants act differently than they normally would because they know they're part of a study. Wording of questions. The way the questions are worded can persuade participants to answer a certain way. So persuade participants to answer in a certain way. And then placebo effect takes place when people who are ill or in pain want a treatment to work so badly that they convince themselves that it works. So that they convince themselves that it works. And they're told a treatment will work and believe that it does. Now, recall that a second sample of Lay's potato chips was collected and the following results were obtained. So the second sample is on top, first sample is on bottom. Now it says, comment on this distribution to that of the original Lay's sample. So we've got both of these graphs here, and they want us to just compare them. Just comment on the distribution. So in the second one, okay, the sample mean, so we've got two things going on. We've got the sample mean of 28.32 and the true population mean of 28.3. So you'll notice these are really close to each other, only about 0.02 of a point off. So we can say the sample mean is really close to the population mean. And data values are more spread out. Which equals a large range of results. So you can see graph number 2 has a much larger spread to it than graph number 1. Now, statistical bias. Statistical bias is the discrepancy between a population parameter and sample statistic. In this situation, the sample mean compared to the population mean. And then the last thing, variability, is the spread of the data. Now, number 6 says, identify each of the following as high or low statistical bias and high or low variability. So A and B. So this one has a population mean right here. And we can just see how the graph is spread out right here, right? Now, since the population mean is way down here and most of our data is up in this area, we can say that this has a high bias. So it is biased towards the high end of the scale. So high bias. And since most of the data is kind of clustered together, really close, we can say there is low variability. Okay? On this one, though, you can see this one, the population mean is way up here, and most of our data is way down here. So instead of a high bias, this one's going to have a low bias. And you can see that most of the data is fairly spread out. We've got some blank spaces here and here, here. So we're going to say this one has a high variability. This one right here. So we got some gaps in the data, right? Because we have some gaps in the data, there's going to be high variability. But see how the population mean is fairly close to the center? So since the population mean is fairly close to the sample mean, there's going to be low variability, low bias. So we have low bias. And since we have gaps in the data, we're going to have high variability. And then the last one, since our population mean and our sample mean are pretty much identical, we can say there is low bias. And because our data is fairly symmetrical, there's not many gaps in the data, we can say that there is low variability.